So we have all these properties of logarithms where multiplication inside a log can turn into adding two different logs. Division inside a log can turn into subtracting two different logs. An exponent inside a log can come down out front and be multiplied by the log. Although if there's addition inside the log, there's nothing we can do. You might wonder, well, where are all these properties coming from? How can multiplication turn into addition? Well, again, it's important to remember what a logarithm is. Logs are exponents. And so the properties of logs come from the properties of exponents. So if you think about x squared times x to the fifth, well, when you're multiplying, what do you do with the exponents? You add them. So when we're multiplying, we add the exponents, because again, logs are exponents. So we're adding two different exponents here. Okay, similarly with division. When you have x to the fifth divided by x squared, when you're dividing, you subtract the exponents. So when we're dividing, we subtract the exponents. And when we have power to a power, we multiply the exponents. So when we have a power inside a power here, well, then we multiply the exponents. Y was an exponent, the log is an exponent. Okay. Well, what about addition? Well, if you have x squared plus x to the fifth, what can you do? Nothing. Adding, you can't add them unless they're like terms. So here, that's why when we're adding, there's nothing we can do. Okay. All right, so let's use these properties here. Let's say we want to evaluate these without a calculator. Okay, of course, in a calculator, you could just type them in, but what if we don't have a calculator? Well, if we look at this, just this first one here, that would be an exponent that we put on 6 to get 4. We would know that exponent, right? We would need a calculator to figure that one out. But notice they have the same base here. And so let's use our log properties. The log properties say adding, so we're going to go backwards, we're going to go from the right to the left. Adding, we can turn this into multiplication. Okay, so it's still going to be log base 6. And then we're going to multiply the 4 and the 9 together. So it's going to be log base 6 of 36. Now look at that. Now that's a really easy problem, right? What exponent do we put on 6 to get 36? That's 2. Right? Again, if you need to show a little bit of work for those, that's fine. If you need to set that equal to x and write down 6 to the x is 36, that's fine. Okay, how about this one here? All right, so we've got subtraction, so it's going to turn into division. Now make sure we do this though, it's just a single log, and then it's the division problem. You're not writing log over log. We don't want to see log over log. It's log and then the fraction. Okay, well that's log base 3 of 27. And then what exponent do we put on 3 to get 27? That's 3. 3 cubed is 27. Okay. How about this one? So 64 to the 10th, that would be a huge number. I'm not even sure if the calculator could handle that. It might be overflow for the calculator. So trying to do that would be pretty hard. Well, let's use our properties here. The property says that these exponents inside a log can come down out front here. So we're going to take the 10, bring it down out front. We're going to have 10 log base 8 of 64. Look at that, log base 8 of 64. That's an easy one. What exponent do we put on 8 to get 64? That's 2. Of course, it's not 102, right? What's in between here when things are next to each other? They're being multiplied. So we multiply those together and we get 20. Okay. So just using those 3 different log properties there. Now what about number 4 here? So subtraction, there was a property where subtraction could turn into division. But notice for all of these here, to use these log properties, you had to have the same base, both base 3, both base 6, both of these base b. This one's log base 5. How about that one? You don't see the base. Remember, when you don't see the base written, that means it's base 10. So this one's base 10, this one's base 5. That means you cannot use log properties here. Okay, so when you see these, this is not a log properties problem. This is just kind of like a 2-for-1 special. It's 2 problems in one. Okay, so pretend like the whole problem is log base 10 to the 10. Okay, so you're trying to figure out 10 to the what is 10. Well, that's an easy problem. If I just gave you that, you could do that. That one's 1. Okay, and then pretend like that's the whole problem. You're trying to figure out 5 to the what is 1/5. Yeah, if I just gave you that, that wouldn't be too bad. You could do that problem. That would be -1. And then just subtract them. It's just a 2-for-1 special. It's just 2 problems in one. It actually has nothing to do with log properties, so make sure you know the difference. Same base, you probably want to use log properties. Different bases, it's probably just 2-for-1 special. Okay? Minus a negative, of course, is adding a positive, so the answer is 2. Okay? So why don't you take a minute and try problems number 5 and 6 here. And so you can check your answers right there. Number 5, you used log properties. And number 6 was a 2-for-1 special, 2 different problems to find here. Number 6 here, the key was to see 25 as 5 squared, because you got this base 5 here. And so then you're trying to find 5 to the what. Remember how we write roots as powers, as fractional exponents. The root is the bottom of the fraction exponent, the power is the top. And so this right here is just 2 to the 7th. And then, of course, adding fractions, we had to make common denominators. So we changed the 2 to have common denominators. All right. So now we're going to just take these things and expand. So this is something that sometimes we have to do in calculus. We have to just kind of rewrite things, either expand or in a minute we'll condense, take these things apart or put them together. We'll sometimes make them easier to work with in calculus. So expand means to make it bigger. So expand, we're going to take things that look like this left side and we're going to make them look like this right side here. Okay. So we've got multiplication here, so we can turn that into addition. So we can say log base 2 of 5 plus log base 2. Make sure you write the base 2 every time. Okay. Of x cubed. And I mean, if you wanted to, you could say like x cubed y here, and then in a separate step, split that one up into addition. But you can, like if there was a z here, we could say plus log base b of z. You can split up multiple multiplications into multiple additions here, and we can just keep tacking this on as plus log base 2 of y. And then there's just one more thing. Again, we're trying to do anything that looks like the left side, we're trying to make look like the right side here. So there's one more property we can use. We can make this exponent come down out front. So we can say log base 2 of 5, bring that down 3 log base 2 of x plus log base 2 of y. All right, so that's expand. Okay, so now what we're going to do is condense. Now we'll go the other way. Okay, so for condense, we're going to take things that look like the right side and we're going to make them look like the left side. We're just going to use our log properties going back and forth, both directions. Okay, so condense, you do have to be careful about which order you would do it in. Okay, so we've got addition, so at some point we're going to do multiplication, and then we also have these numbers out front. So at some point these numbers out front are going to become exponents, but it's important what order you do this in. So think about whether you want to make the numbers be exponents first or whether you want to turn the addition into multiplication first. And the first thing that you should do is turn those into exponents, because we've got these separate numbers. So we need to know which number goes on which part first before we start combining things together. All right. So we're going to make this log base 4 of x to the 1/2 plus log base 4 of x plus 1 cubed. And then we can make the addition turn into multiplication. So we can say log base 4 of, and then x to the 1/2. Probably good to write that. That's what it is, x to the 1/2. That's a square root of x. And then times that x plus 1 cubed. Again, turning addition into multiplication. All right, so why don't you go ahead and try
a couple of these problems now, expand and condense. Again, just going back and forth with the log properties, either splitting apart or putting it together. Go ahead and give those two problems a try. All right. So here is the answer for the first one. So here we change that division into subtraction, and then a square root is a 1/2 power. And so we write that as a 1/2 power, and then that exponent can come down out front. Make sure you have these parentheses here. If you didn't have the parentheses, if you had log base 7 of 3x plus 5, that would be log base 7 of 3x, and the plus 5 would just kind of be hanging out there, not in the log. So it is very important that we still have those parentheses there to indicate that the whole 3x plus 5 is inside the log. All right. And then for this second one here, there's a couple ways you could do it. So the first way would be just to treat all these three things separately. You could kind of, what you can do is anything that's subtracted would be on the bottom of the fraction. So if you wanted to, you could jump kind of right to saying natural log of having the x plus 2 squared, and then the x and the x plus 2 in the denominator. Anything with a negative in front of it would be in the denominator, and then anything that was positive would be in the numerator. So you could kind of jump right to that step, and then get to your answer from there. If you weren't sure about that, though, what you could do is you combine the first two together into one fraction, and then you've still got subtraction, so you could have that fraction divided by this. And then, of course, complex fractions. Fraction is just a division problem, so you can change that fraction to division. Division, we multiply by the reciprocal, and then it works out. So kind of a few different ways you could look at it, but there actually was an even simpler way to look at it. If you look at this here, you actually had 2 of natural log x plus 2 minus 1 of natural log of x plus 2. So 2 of this minus 1 of this leaves you with just one of them there. It's like if you had 2a minus a, that would equal a. 2 of something minus another of it just leaves you with one of it, and then that gets you the answer pretty quickly there.